Hello everyone, it's that teacher here, and today's lesson is going to be on long division. Let's start learning. Welcome back to the channel everyone. We're going to begin our lesson on long division. Now long division is more of a traditional old school method of division. It's not commonly seen in schools at the moment when you're dealing with dividing numbers by one digit. However, it's the foundation we need to understand in order to divide numbers by two digits. So it's the more common method when you're dividing large numbers. So we're going to do a basics lesson of long division, and in our next episode on the channel, we will cover division of numbers by two digits. For example, 1000 by 27, something like that involves long division. So this lesson is more of a foundational basics. We're going to cover the basics of long division, and our next episode will be that step up. Let's get straight into this lesson, the basics of long division. Now, our first question, 5,347 divided by 4. How many 4s can fit into 5? That would be 1. Now, with long division, we bring down the remainders, just like this. Now, we use whatever number comes next in the question, which would be the 3 in the hundreds column. We bring down next to our remainders, creating a new number, 13. How many 4s can fit in 13? That would be 3. Bring down any remainders. That's the trick with long division. Any remainders need to be brought down just like this. It's quite simple once you get the hang of it. Remainders, bring down. Now our next number, the 4 in the tens column, we need to bring down next to the remainder. Remember, you're bringing down the next number, creating 14. Now how many 4s can fit into 14? That would be 3. Remainder, bring it down, remainder 2. Now finally, the 7 in the ones column, or the units column, depending on what country you're in, goes next to our 2, creating 27. How many 4s can fit into 27? That would be 6. Now we've used 24 of the 27 numbers. First of all, our first example we're going to cover is just going to be simple remainders. So remainder 3. Our next example will have fractions as remainders, and the third example will have decimals as remainders. I want to make sure that we cover all 3 remainder types on this episode to ensure that you have a comprehensive and thorough understanding of this concept. So the answer here would be 1,336 and remainder 3. Now, moving on to the next number, remember we're going to have remainders as fractions here. Follow exactly the same method. How many 3s can fit in 8? That would be 2. Bring down the remainders. Once you've brought down the remainders, move to the next number, which would be the 8 in the hundreds column. Bring that down next to that 2. How many 3s can fit in our new number 27? That would be 9. Remainder 1. Bring down the 6 in the tens column. How many 3s can fit evenly into 16? That would be 5. Remainder 1. As you can see, it's quite simple. Just bring down the remainder, and then whatever number comes next, bring next to it. So the 1 in the ones column or the units column, bring down next to our remainder, creating the number 11. How many 3s can fit into 11? That would be 3. Now the trick with remainders as fractions, or fractions as a remainder, is you have 2 remainders here because we've used 9 of 11. So we have 10 and 11, we have 2 remainders. The remainders become the numerator, the top number in our fraction. Now, the divisor in our question here is the 3. So we're dividing 8,861 divided by 3. The 3 is the divisor. Now, the divisor becomes the denominator. So the 3, whatever you're dividing the large number by, becomes your denominator when you have remainders as fractions. So the answer here would be 2,953 and 2/3. Finally, our last example. The remainders are going to be decimals this time, using our long division method. How many 6s can fit into 1? That would be 1. Bring down the remainder, that would be 1. Now, whatever number comes next, in this case, is the 3 in the hundreds column. We bring down next to the remainders, creating 13. How many 6s can fit evenly into 13? That would be 2. Remainder, bring it down, 1. Now remember, move to the next number, the 7 in the tens column. Bring it down, creating 17. It's important that you layer the arrows. As you can see here, you need to have like levels so that you don't confuse the 13 with the 17. They need to be, the 17 needs to be lower than the 13. Follow my format with the long arrows, just so you don't get confused. How many 6s can fit into 17? That would be 2, remainder 5. So no matter how large the remainder is, you still just follow the same process. Bring the 9 down. How many 6s can fit into 59? That would be 9. So we've used 54 of the 59 numbers. We have 5 remainders. Before we use our remainders, we need to use our division trick when it comes to decimals. 1 high, 1 low, and 2 zeros. So 1 decimal point high next to your answer, 1 decimal point low next to that last remainder, and 2 zeros. So 1 high, 1 low, and 2 zeros. That's our trick with decimals as remainders. So, like I said previously, we have 5 remainders from our last question. We put it next to the new 0. So how many 6s can fit into 50? That would be 8, remainder 2. Put the next remainder next to the next 0 that we just added, creating the new number 20. How many 6s can fit evenly in 20? That would be 3. Now, usually I would stop at 2 decimal places. If you go any longer, some of your remainders could be 15 numbers long. That could be massive. So usually a teacher wants to the closest 2 decimal points. So in this question, we're going to leave it here at 1229.83. If you want to add a few more zeros, you can and follow the same process. However, if you get to the closest 2 decimal places, you're going to be fine. That answer is going to be correct. Now, it's your turn. Your question for your book, students, is 7,839 divided by 8. Now, I've gone through the trouble to show you the exact working out to make sure that you understand what you're doing, and hopefully you've learned from our examples. If you're finding anything confusing, flick back to any of the different 3 examples that we did on the channel and just follow those processes and practice. Get a bit of paper, write yourself some questions and try and figure them out. So your answer's coming up. Here it is. Now, as you can see, I'm going through the answers here. 7,839 divided by 8. We're going to end with decimals as remainders. So in this question, you can see we've added the 1 high, 1 low, and 2 zeros. And this time we're going to add in a 3rd 0, like I said here, because we had a few remainders left over. If you want to be really precise, 3 decimal places, the closest 3 decimal places would be really effective. So as you can see here, the answer would be 979.875. That's as accurate as you can get. And that's how you solve long division. So hopefully this video has helped you understand long division. In our next episode, we're going to get into division with 2 digits. So for example, 7,839 divided by 18. So if you have this foundational knowledge, you're going to be fine for our next episode. Thank you for watching. We'll see you then. It's that teacher. Thank you.